Hey guys, happy Monday, and we are continuing this with quadratics. So we're stepping into what we call the area model, and if you think back to probably 6th grade, maybe even earlier, you just heard of the term area, and area is really connected to what we've been doing with factoring, and it's connected with quadratics that one of the key characteristics is it's x squared. It's x times x. All right. So with that said and that in mind, get your TOC 512 and let's get going. All right. So the warm up. Here we have 4 rectangles and they have numbers. These numbers represent the side length. So from right here to right here, this length is 6. And then from right here to right here, this length is 4. So if I wanted to know the total length, I would say 6 plus 4, which would give me the total length of 10. So that's kind of how we read these. If we have more than one length, like over here, we've got 3 and then a 1. To find the total length of that side, we just add them together. 3 plus 1 is 4. So these outside lengths, right, are just that, outside lengths. Okay, so how does that help me find x? Now, x is from here to here. Where else do you see that exact same length? I'll give you a second. Okay, so you should see it right here, right across from it. Now, I don't know how much this is. There's nothing labeled there. So it's exactly the same length as this, right? That stops there. So x would be 3. Now, y is right here, and y, using that same logic, would be 1. Okay, so perimeter is just adding up all those sides. So I could say 6 plus 4 is 10. And then 3 plus 1 is 4. And now over here, again, x is 3, y is 1, 3 plus 1 is another 4. And on the bottom, if the top is 10, if that length is 10, the bottom would also be a total of 10. All right, so that gives me a total of 28. Again, I do expect you to do the perimeter, but that's not going to be the focus of this video. We are going to focus on area. Now, the area formula is A equals L times W. Now, if you think back to the lessons we did last week, if we have a number like 6, and that's equal to 2 times 3, those terms are called factors. So 2 and 3 are factors of 6. In the same way, the length, right, this length and the width are both factors of that area expression. All right, so I look and I see, okay, the top length is 6 plus 4 or 10. So 10 times, and 3 plus 1 is 4, 4. Again, I don't care if you write it as 10 times 4, which is 40, or 4 times 10, which is also 40. So I don't care which one comes first. And that is because the commutative property allows me to go either way. All right, so here I can look at this as either 2 separate rectangles or as one big rectangle. It would give me the same answer for the area. And again, I'm going to ignore perimeter right now. Just remember, it is the sum of all the sides. And I do expect you to do it. But we are focusing on area. So if I just look at this length, right? So I know that the area is equal to that 3 times, and then I look at the other side length, the other factor, right? I have 5 plus 3, which gives me 8. Okay, so my area here, which is all of this inside stuff, my area there is 24. I could also rewrite this, instead of saying 3 times 8, I could rewrite it as 3 parentheses and then whatever is on the top. So I have the first factor, which is this one side, and then the second factor, which I'm not going to write 8, which I could. I'm going to write it out as 5 plus 3. 5 plus 3. Okay, and if I follow my PEMDAS, 5 plus 3 is 8, and 3 times 8 is 24. I could also do distributive. 3 times 5 is 15, and 3 times 3 is 9. And guess what that equals? 24. You betcha. Okay. All right. So here, the only thing that's different, and again, it's like, oh, this is so easy. I learned this in 6th grade, but now we have a variable. Okay, so make sure, even if you think you kind of got it, that you're really doing the work and you are really putting in some effort here. So when it does get a little bit more difficult, you don't get lost. All right, so here we go. I've got my area. So I have my length times my width. Again, either of them could be the length or the width, right? So I have area is equal to 8 times x. And we don't normally write 8 times x. We just write it as 8x, right? So exactly the same thing that I would do if it was numbers. The only difference here is I keep the x as a variable. Okay, so this one was pretty easy except for the directions I felt. I felt it looked a little different. So all this expects you to do is, if they say A, they just want the smallest length. So if I'm doing A times B, then the side that A is on should be smaller than the side that B is on. So here I can just say A is a little bit smaller of a side times B, which is a little bit longer of a side. Right? And then the area here would be AB. All right. Now over here I have X. X is actually the longest side. So X is super long side. B is a pretty long side also. So this is going to be a bigger rectangle than my first example. So I'm labeling the longer side X, the shorter side B, and my area would be BX. Cool. All right, so now we have X, which is our longest side, right? And I'm actually, how do I want to do this? All right, let me do the longest side here, right? So X. Now I want to multiply it by A, or sorry, multiply the X by A, which is the shortest side, right? I think I said it wrong the first time. So that's one rectangle. And then B is a little bit longer than A, but probably not as long as X, right? And as I am obviously demonstrating, this does not have to be perfect. So the area for this first rectangle would be AX. And for this second rectangle, it would be BX, because I'm saying A times X, just like length times width, and that gives me my area. So my total area would be AX plus BX. I don't know if you can see that all that well. Okay. If you are feeling really ambitious, you can get that same value by distributive property. So X times A is XA, or remember you can reverse them, use that commutative property, and X times B is the same thing as BX. So the reason that they did that is they're trying to get us to activity 3, which is towards the end of your paper. And these are called algebra tiles. So I don't know if you've ever heard about algebra tiles, but this is what they are. They have them as little like chips that you can hold. You can also draw them, which is where we're going to be spending the majority of our time. Okay. And the way these algebra tiles work is that you have the bigger ones, and both of the sides for those bigger ones are x. So it's a square, right? And in fact, x times x gives me x squared. So all of these squares, right? So this looks like a square. I've got a length of x all the way around. And over here, those are always going to be x squared algebra tiles. All right, so now these guys, right, which are the same length this way, but they're a little shorter. Okay, those are x's. So the side is supposed to have the same side as this guy, right? But the other factor, the other length, is just 1. So it's really x times 1, and that gives you those longer, kind of skinnier x values. All right, and then we have little itty bitty guys, which we don't see here, kind of a little bit, and those are 1 by 1s. So those are 1s. All right, so those are the algebra tiles that they are kind of representing in this picture here. All right, so standard form are the inside, right? So these are the inside, okay, of the area. Okay, so I have y equals, and I'm going to add up the number of x squared. So I have 1x squared plus another x squared. That gives me 2x squares. And now I'm going to count the x's. I want to write it in standard form. So I go from the highest exponent terms, combine those, and then the next highest, which would just be the invisible ones with all these x's, and combine those. So I've got 3x plus 3x. Let me do this over here because it seems a little. 3x plus 3x, and then minus x, minus x, and then minus another x. All right, so 3 plus 3 is 6x, and a negative x minus x, remember those invisible ones? So negative x minus x is a minus 2x, and 6x minus 2x is a positive 4x. Okay, and then negative 3 minus 3 is a negative 6. So standard form again, we write the biggest exponent first, which is in quadratics, always a 2, always squared. And to do factored form, oh shoot, I might need to erase something. All right, in factored form, these are the sides. So it's like side times side, right? Anytime you're multiplying, those are the factors. And that's why it's called factored form. So I'm just going to erase this. Sorry, guys. Okay. All right. So, okay. So here we go. This length again for an x squared is always x. So x times x. And if I keep going from here to here is also an x, right? And now those longer skinny ones, all right, I still have an x value, but it's actually over here, right? So here I have -1 and -1, all right? And I'm getting that because x times -1 gives me negative x. And this length, again, is x. So x times -1 is a negative x there. That's where I'm getting -1 from. All right, so remember, whenever you're multiplying the sides, they need to be equal to what is inside that rectangular shape. All right, so using that same thing, here I know that this side is x because I look above it, right? And that side is x, and here x. And now x times 3 would be the only thing to give me 3x. And that happens twice. All right, so if this side is 3, then I go all the way across, and this side would also have to be 3. So 3 times a -1, and again, this -1 matches that -1, right? And -1. Cool. So again, the factors, I just have to look at one of the width lengths and one of the top lengths. All right, so what am I going to do to combine those? If you said add, you are absolutely correct. Let me put this in parentheses. I have x plus 3 because that's what I see here. I see x plus 3 gives me that length. And I'm going to multiply it, so I'm going to make the parentheses touch. And now I'm going to put the top length. So I see not 1, but 2 x's. So I'm going to put 2x, because remember, I'm adding to get the full length. All right, so I've got 2x, and then -1 minus 1 gives me a -2. So again, the top one is in standard form. That's just adding all of the areas together, all of the insides. And for the second one, I am actually writing that same equivalent expression, but I'm writing it out as factors. So if I were to multiply x plus 3 times 2x minus 2, you better believe it would give you the standard form of 2x squared plus 4x minus 6. Okay, so any questions, write it down, upload it to your note tracker. Take responsibility for your learning. Google it. Try to figure it out. If you're like, hey, I didn't quite understand it, see if you can work it out. Ask a friend. You know, all those things that we can't really do because we're not in class. Give them a call and be like, hey, did you get TOC 512? I was confused about this, right? So talk it out. Try your best. And then you're more than welcome to come to office hours. Mr. Q and myself, we're, quarantined in, and we love seeing your faces, hearing from you. So please, if you need extra support, reach out and let us know. Okay, that's what we're here for. So have a good day. Good luck with all your work, and I will see you tomorrow.